Welcome to Quantitative Aptitude session on numbers. In this part 4 video, we will see about division algorithm and progression. Let's get started. Let's start the video with division algorithm. If we divide a number by another number, then dividend is equal to divisor into quotient plus remainder. Just remember this thing. It will help a lot to solve the problems which is related to division algorithm. Dividend is equal to divisor into quotient plus remainder. And there are some more rules which is to be remembered to solve the problems. I am reading that x power n minus a power n is divisible by x minus a for all values of n. So for all values of n, x minus a is divisibility of x power n minus a power n. And x power n minus a power n is divisible by x plus a for all even values of n. Similarly, x power n plus a power n is divisible by x plus a for all odd values of n. Just try to remember these rules. This will help a lot in solving problems. Let's solve some of the example problems. Please take your notebook and pen and please try to solve it with me. I am reading the problem statement. On dividing 15968 by a certain number, the quotient is 89 and the remainder is 37. Find the divisor. So they have given dividend and the quotient is 89 and the remainder is 37. So we have to find the divisor. We know the formula. Let's solve this. Let's see the solution. We know the formula. Dividend is equal to divisor into quotient plus remainder. So here we have to find the divisor. So accordingly, I'm reformatting the given equation. So I'm subtracting the remainder from dividend and then I'm dividing the dividend minus remainder by quotient. So this is how we have reformatted the given equation. So accordingly, we can put the values. The dividend is 15968 and the remainder is 37 and the quotient is 89. So we are subtracting 15968 minus 37 and we are dividing the answer by 89. So we are getting 179 as the answer. Let's move on to the next problem. I am reading the problem statement. A number being successfully divided by 3, 5 and 8 leaves remainders 1, 4 and 7 respectively. Find the respective remainders if the order of the divisors being reversed. Let's see the solution. So, a number with if it is divided by 3, 5 and 8, we should be divided the given number in this order only. Like first we have to divide by 3 and then by 5 and then by 8, which will leave the reminders as 1, 4 and 7. And we have to find the reminders if the order of the divisors is reversed. So first we have to find the value of the numbers. So I'm considering the number as x. So first I'm dividing the given number by 3. So from the problem statement, we understand like it will leave the remainder as 1. So on dividing x by 3, we are getting some value. That is the unknown value. Here I am considering that unknown value as 1 and the remainder is 1. Then we are dividing the given value by 5. If you are dividing that by 5, we are getting one more unknown value which is z. And then we are getting remainder as 4. Then then we are dividing the given number by 8. So in that case, we are getting the remainder as 7. So to find z, first we have to multiply these two values, which is 1 and 8. And then we have to add the remainder. So 1 and 8 plus 7, which gives 15. That is the value of z. To find y, we are multiplying 5 into z. So in place of z, we are replacing 15 and then we are adding the remainder, which is 4. So in this case, we are getting 5z plus 4, which gives 79 as the answer. So here y is 79. And then to find x, we are multiplying 3 and y, and then we are adding the remainder as 1. So in place of y, we have to replace 79. 3 into 79 plus 1, which gives 238. Now we know the values. Then we have to see if the devices are getting reversed, we have to find the respective reminders. We know the value of x, which is 238, and then we have to reverse the devices. First we have to divide it by 8. So on dividing 238 by 8, we are getting 29 as the answer, and the remainder is 6. Then we are dividing the given number by 5. On dividing 29 by 5, we are getting 5 as a quotient and 4 is the remainder. Then we are dividing it by 3. On dividing 5 by 3, we are getting 1 and the remainder is 2. So the respective reminders are 6, 4 and 2. This is the answer. Let's move on to the next problem. I'm reading the problem statement. A number when divided by the sum of 555 and 445 gives 2 times their difference as the quotient and 30 as the remainder. The number is, they have given 4 options: 1220, 1250, 22030, 220030. So from the problem statement, we can understand like when a number, that is the unknown number, if that unknown number is divided by the sum of 555 and 445, which will give the quotient as 2 times the difference of 555 and 445, and the remainder is 30. So we have to find the unknown number. Let's move on to the solution. So here I'm considering the unknown number as x, and they have given devices, which is the sum of 558 and 445. So I'm adding 555 and 445, which is 1000. So the divisor here is 1000, and the quotient is 2 times their difference, as which is the quotient. So 2 times into the difference. The difference is 110, which is multiplied by 2, which gives 220, and the quotient is 220, and the remainder is 30. We know the remainder, which is 30. So we know the formula. Dividends equal to divisor into quotient plus remainder. Then we are replacing the respective values. Here the divisor is 1000 and the quotient is 220 and the remainder is 30. So 220 into 1000, which gives 220000 plus 30. So the answer here is 220030, and the option D is the correct answer. Let's move on to the next problem. And the problem is, a number when divided by 114 leaves the remainder 21. If the same number is divided by 19, then the remainder will be. And the options are 1, 2, 7 and 21. So from the problem statement, we understood like when a number is divided by 114, it will give the remainder 21. If the same number is divided by 19, then we have to find the remainder. Let's move on to the solution. I'm considering the number as x, which is the dividend. And we know the formula, which is dividends equal to divisor into quotient plus remainder. So from the first problem statement, we can write like this, which is dividend is x, and here the divisor is 114, and they haven't given any information about the quotient. So I'm keeping q as it is, plus the remainder they have given is 21. So this is the equation 1. And from the second problem statement, we can write like this, which is here the dividends equal to x, and the divisor is 19. So 19, and here also they haven't given any information about quotient. So I'm keeping q as it is, and then here we have to find the remainder, so which is r, and this is the second equation. So first, I am expanding the first equation, which is x equal to 114q plus 21. So 114 can be rewritten as 19 into 6, and we have q into q plus 21. 21 also can be rewritten as 19 plus 2. I'm writing like this because I'm going to take 19 as a common term from both the terms. So here it can be written as I'm taking 19 out of 2 terms, and here we will be having 6q plus 1 plus 2. So we know this is in the format of the above equation, which is dividends equal to divisor into quotient plus remainder. Dividends equal to divisor into, this is the quotient plus remainder. So here the remainder is 2. So the option is B. Just by comparing the equation with the formula, we are finding the remainder here. We have seen some of the example problems, and this is the exercise problem for you. Please try to solve it. We will see the solution in the upcoming video. I am reading the problem statement. When a number is divided by 13, the remainder is 11. When the same number is divided by 17, the remainder is 9. What is the number? And they have given 4 options. Option A is 339, option B is 349, option C is 369, and option D is data adequate. Please try to solve, and please try to remember all the equation we have, all the formulas we have seen, and try to solve this. And there is a one more exercise problem for you. Please try to solve this problem. I am reading the problem statement. In doing a division of a question with zero remainder, a candidate took 12 as a divisor instead of 21. The quotient obtained by him was 35. The correct quotient is, options are 0, 12, 13 and 20. Just remember all the formulas we have seen, and please try to solve it. We will see the solution in the next video. Next we will see about progression. What is progression? A succession of numbers formed and arranged in a definite order according to a certain definite rule is called a progression. Like, it is having a sequence of numbers and it is formed and arranged in a definite order, and it will be according to a certain definite rule. Then that is called progression. We have two types of progression. One is arithmetic progression, which is also called as AP, and geometric progression, which is also called as GP. We will see about that. First, we will see about arithmetic progression. What is AP? If each term of a progression differs from its preceding term by a constant, then such a progression is called arithmetic progression, which is also called as AP. Let's understand the statement with the sequence. This is the AP and this is the arithmetic progression. We have A in the first term and A plus D as the second term, and A plus 2D as the third term, and A plus 3D as the fourth term, and it will go on like this. So if each term differs from the preceding term by a constant, that means if you are trying to subtract the second term and the first term, we'll be getting D. And similarly, if you are trying to subtract the third term and the second term, you are getting the same D as the answer. And if you are trying to subtract this fourth term and the third term, you are also getting D as the answer. So we are getting a constant D. That means if the if each term differs by the preceding term by a constant, then that progression is called arithmetic progression, which is also called as AP. So here this is the sequence, this is the AP sequence, and you can understand A is the first term and D is the common difference. We have to remember some of the equation for arithmetic progression. So if you want to find the nth term of the AP, like the final term of the AP, you have to use this equation, which is Tn equal to A plus n minus 1 into D. And if you want to find the sum of n terms of the AP, then the formula is Sn equal to n by 2 into 2a plus n minus 1 into D. Or it can be also calculated with another formula, which is Sn equal to n by 2 into first term plus last term. So according to the given equation or given sequence, we have to use the respective formulas. And for AP, we have some more formulas to remember. Here for the sequence, which is 1 plus 2 plus 3 plus up to n, we will be getting n into n plus 1 by 2. So based on the value of n, you have to replace this equation and you have to find the answer. And the second equation is 1 square plus 2 square plus 3 square plus up to n square, which gives n into n plus 1 into 2n plus 1 by 6. And the third formula is 1 cube plus 2 cube plus 3 cube plus up to n cube, which gives n square into n plus 1 the whole square by 4. Next we will see about geometrical progression. What is geometrical progression? A progression of numbers in which every term bears a constant ratio with its preceding term is called a geometrical progression. It is also called as GP. You know, in case of AP, each term differs by the preceding term by a common difference. But in case of GP, each term differs by the preceding term in terms of constant ratio. Now let's see the GP. This is the sequence of GP, and in the first term we are getting A, and AR is the second term, AR square is the third term, and AR cube is the fourth term, and it will go on like that. So in this sequence, if you are dividing the second term by the first term, we are getting R as the ratio. And if you are dividing the third term by the second term, we are getting R as the ratio. If we are dividing the fourth term by the third term, here also we are getting R as the ratio. That means we are getting a constant ratio. So in GP, each term differs by the preceding term by a constant ratio. So here A is the first term and R is the common ratio. Similar to AP, for GP also we have to remember some of the equations. To find the nth term of the GP, the equation is Tn equal to AR power n minus 1. And to find the sum of the n terms of the AP, the formula is Sn equal to A into 1 minus R power n by 1 minus R. Just try to remember these equations. These formulas will help you a lot to solve the problems related to arithmetic progression and geometric progression. Let's try to solve some of the example problems. Please take a notebook and pen and try to solve along with me. I'm reading the problem statement. Find the sum of all odd numbers up to 100. We have to find the sum of all the odd numbers which is below 100. Let's move on to the solution. So the given numbers we know as 1, 3, 5, 7, 9 and up to 99. So these are all the odd numbers which are below 100. We have to we have to find the sum of these numbers, and we know this is the sequence of AP because each term differs from the preceding term by a common difference. Here the common difference is 2 because 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. Similarly, it will go on. We know the formula for finding the sum of the numbers in the AP. Here from the sequence we understand like we know the first term and we know the second term. So we are using the equation which is n by 2 into first term plus last term. So in that equation we don't know the value of n. So to find the value of n, we have to use the formula of nth term of AP because we know the nth term of AP and we know A and D also because A is the first term and D is the common ratio. So here A equal to 1 and D equal to 2. So from the equation of nth term of AP, we can easily find the value of n. So this is the formula for finding the n. Tn equal to A plus n minus 1 into D. So the Tn is the last term which is 99 and A is 1 and D is 2, which is the common difference. So we are replacing the respective values in the given equation, and from this equation we are finding n as 50. Here we are getting n as 50. And then to find the sum of the numbers, we have to use the formula n by 2 into first term plus last term. We know n, which is 50, and the first term is 1 and the last term is 99. First term is 1 and the last term is 99. So we can replace the given values, which is 50 by 2 into 1 plus 99. 1 plus 99 is 100. 50 by 2, which is 25. So on multiplying this, we are getting 2500. So this is the answer. Let's move on to the next problem. The problem is 2 plus 2 square plus 2 cube plus up to plus 2 power 8. What is the value? So by looking into the problem statement itself, we can understand like the given series is a GP, which is a geometrical progression, because each term differs by the preceding term by a common ratio. In this case, 2 square by 2, which gives 2, 2 cube by 2 square, which is giving 2. So this is the sequence of GP. So here the first term is 2. So here A is equal to 2, and the common ratio R is 2, because if you are dividing the each term by the preceding term, we are getting 2 as the ratio, and then we are getting n as a 8 here. So we know that the formula sum of the n term is A into 1 minus R power n by 1 minus R. So here we are rewriting as R minus 1 in the denominator. Why? Because R is 8. Oh, sorry, R is 2. So R is greater than 1. So we can reformat this equation. By replacing the respective values in the given equation, we are getting like this. It is equal to A 2 into 2 power 8 minus 1 by 2 minus 1. On solving this, we are getting 510 as the answer. Let's move on to the next problem. The sum of first 45 natural numbers is, options are 1035, 1280, 2070, 2140. Let's try to solve the problem. So the given series is AP, because the first 5 natural numbers are from 1 to 45. So we have to find the sum. So 1 plus 2 plus 3 plus up to 45. And the given series is AP, because each term differs from the preceding term by the common difference, which is 1. 2 minus 1 is 1, 3 minus 2 is 1. Similarly, it will go on. So the given series is AP. Do you remember this equation? We have seen this. 1 plus 2 plus 3 plus up to n, which gives n into n plus 1 by 2. We know that n is the last term. Here n is 45. So we are replacing n in place of, we are replacing 45 in place of n. So 45 into 45 plus 1 by 2. On solving this, we are getting 1035 as the answer. So option A is the correct answer. Till now, we have solved some of the example problems, and this is the exercise problem for you. Please try to solve it. We will see the solution in the next video. And the problem statement is 51 plus 52 plus 53 up to 100. And the options are 2525, 2975, 3225, 3775. Please try to solve it. We will see the solution in the next video. And there is one more exercise problem for you. Please try to solve this problem as well. The value of 11 square plus 12 square plus 13 square plus 14 square plus up to 20 square. And the options are, option A is 385 and option B is 2485. Option C is 2870 and option D is 3255. That's all about this video. In the previous video, which is the part 3 video of quantitative aptitude session on numbers, we have seen about multiplication by shortcut methods and basic formulae. If you are interested in those topics, please watch my previous video. In that video, I have given 2 exercise problems. Here, we will discuss the solutions of the 2 problems. Let's get started. Let's see the first exercise problem. I hope you have solved this problem, please try to compare my solution with your solution. If you are getting the correct answer, then you are good to go. If you are getting a wrong answer, then no problem. Please rewatch my previous video and try to recollect all the topics and try to solve again. Now we will see the solution of the first exercise problem. Here, evaluate 217 into 217 plus 183 into 183, and the options are 79698, 80578, 80698, 81268. Let's see the solution. So here we are having 217 into 217. So we are rewriting as 217 square. Similarly, for 183 also we are writing as 183 square. So we have to reformat these two values either in the format of a plus b the whole square or a minus b the whole square. So for 217 we can rewritten as 200 plus 17. This in the format of a plus b the whole square. And for 183 we can rewritten as 200 minus 17, which is a minus b the whole square. So we know the formula of a plus b the whole square plus a minus b the whole square, which gives 2 into a square plus b square. So in place of a we are having 217. In place of b we are having 183. So replace the values in the given equation. 2 into 200 square plus 17 square. On solving this we are getting 80578 as the answer. So option B is the correct answer. Let's move on to the second exercise problem. Evaluate 856 plus 167 the whole square plus 856 minus 167 the whole square by 856 into 856 plus 167 into 167. And the options are 1, 2, 689, 1023. Let's see the solution. So here I am assigning A for 856 and B for 167. So it is in the format of a plus b the whole square plus a minus b the whole square by a square plus b square. So I'm trying to expand this a plus b whole square and a minus b whole square. We know that a square plus b square plus 2ab is a plus b the whole square. For a minus b the whole square, it is a square plus b square minus 2ab. So here we have plus 2ab and here we have minus 2ab. So we are cancelling that. As a result of that, we are getting a square plus b square plus a square plus b square minus a by a square plus b square. So here we can rewritten as 2 into a square plus b square by a square plus b square. We have common term which is a square plus b square in both numerator and denominator. So we are cancelling that and we are getting 2 into 1, which gives answer 2. So option B is the correct answer. If you found this video helpful, please like, share and comment this video. If you want to stay up to date with our latest content, please subscribe to my channel Spider Tech Hub. Thank you.